f of x is your output on the function f, and g of x is your output on the function g. So how many functions do we have? 2, right? Now, it's only asking us to solve for one thing. There is exactly one solution for which f of x equals g of x. Now, if we think about that, we got to go back to Frank's class. If we determine solutions on a graph, how do we see the solution on a graph if there are 2 graphs? The point where they intersect. How can I use that information, or how can I go to my table to help me with that information? What are some different strategies?
Can you make an equation?
Well, that would, you could, but that'd be even too much work. You have everything you need.
Find the relationship between
Are these just a bunch of points?
Well, I did okay, so
Yeah.
So I went from the point okay, between 5 and 6 is
Here's a big clue. You want them to be equal, right? Look at 5 and 6.
is when they were close.
Are these when these numbers are getting close to each other?
Yeah.
If you look at this, our y values here, negative 5 to 11, are they anywhere close to this? No. Let's go ahead and plot these points, just these in here. So go 5, 20. So our first point here is 5, 20. And we can just sketch, we're just, say 520 is right here. Okay. And then 535 is our other graph. I'll do it in another color. You know what? I'll do 631 for this one too. So 520 is there. 631, it goes up. This is for both this is for graph F. Okay. So this is one point. Here's another one. Okay. This is for graph F. Those are my 2 points. Draw the line. Okay. And I mean, you don't even have to do all of this. You could probably just see here, but I want to show you why. And then G is going to use the same values, except instead of using 5 and 20, it's going to use 5 and 35 and 6 and 18. It's really just how you read the table. So 5 and 35 is up here. 5 and 35. And 6 and 18 is way down here. And you don't even have to be that accurate, but you can see, is there a point of intersection? So you can see these other numbers, these get big and these get small. There's going to be nothing here. So what is the interval on which the solution comes? Between 5 and 6. Okay? That's where your solution is. Okay? Could you graph the whole thing? Yeah. And guys, you have no time limit on this test. Okay? 682. Okay. Consider triangle ABC where angle C is a right angle. It's a right angle, right? Okay. Now, right angle, we're dealing with right triangles. We can think of the unit circle. Okay? Here. Cosine on the unit circle is your x or your y coordinate. Oh, shoot. Why am I not there? Okay. It's your x coordinate, right? So this is, where's your x coordinate less than your y coordinate? Where is your x coordinate equal to your, where's your x coordinate greater than your y coordinate?
Isn't this when you were doing 30, 60, 90?
Kind of. I mean, this is the unit circle. And look at all your angles. They're all in quadrant 1. So let's just start in the middle. Where are your x and your y coordinate the same on the unit circle? 45 degrees. What's the x coordinate at 45 degrees? Rad 2 over 2. What's the y coordinate at 45? Rad 2 over 2. Done with that one. Okay? Now we only need to get one more of these and this problem is pretty much done. Where is your x coordinate less than your y coordinate? This is where you got to visualize the unit circle. So here's 45 is right here.
Above 45. Over 6.
So as we move this way, is our x coordinate getting smaller or bigger? It's getting smaller than my y coordinate. So anything greater than 45 goes in here, which is 65, 55, 75, and 85. That's all you got to do. And then do you know where the rest go?
All in your
Where do all the rest have to go? There you go.
Good question.
Yeah?
Yeah.
Okay.